Welcome to Dear SQL DBA, a podcast for and about SQL Server DBAs. I'm Kendra Little. This week's question is about performing a schema change that is more complex than it seems at first. Here's the question. Dear SQL DBA, I have a 120 gig table with 2 billion rows, and the clustered primary key is on an INT column. What's the best way and the fastest way to convert this INT column to a big int? The database is in the full recovery model, but I can take a downtime for up to a day on the weekend. With concern, billions and billions served. Well, this is a tricky one, and if you haven't run into this issue before, if you have an int column in a table and you're doing something like using it as a primary key and possibly you've got an identity on it and every row gets a higher number when it comes in, eventually you can run out of ints. You can actually run out of numbers because the integer data type in SQL Server supports numbers up to about 2.147 billion with a little bit of change. So literally, if you're using this each new row gets a higher number, and you get to the maximum value allowed for an integer, the next time a row comes in, it literally can't have a higher number because it doesn't fit in that data type. And so at that point, you have to do something to be able to get more rows into your table. And you do have a bunch of options, some of which are easier and some of which are harder. The first thing that we think of is, well, I'll just change the column, from int to a big int. But the issue with that is that it's not that fast. So, we have this hope of maybe it'll be really fast. No, this one isn't fast in a large table. If we have a small table, we may be able to take care of this pretty quickly. But our questioner has a large table. The first thing you figure out is you can't change the column from an int to a big int with your clustered primary key on there. It's like, oh, no, you can't change the data type when I've got dependencies on it. I've got a whole index on it. So you've already got to say, oh, well, I've got to remove the clustered primary key. We're already in the situation of like an outage here, right? And we haven't even sort of confronted, well, what happens if we have other tables who have foreign keys or are dependent on this primary key, or what if the table is in transactional replication or something, right? So even just with this first bump in the road, we're like, oh, we are going to need to take a downtime if we're just going to alter the schema. But even when you get to the point where you remove all the dependencies and you can alter the column, you immediately start saying, hey, this is really slow. And the other thing you notice, not immediately, but fairly quickly, is that your transaction log starts filling up. If you have auto growing on, your transaction log starts growing. And on large tables, depending on whether or not your transaction log is as big as the state of Alaska, your transaction log may fill up the drive and the transaction may roll back and be incredibly slow because most rollback operations in SQL Server are single-threaded. The reason that it's using so much transaction log and is also slow is that changing this column from an int to a big int is what's called a size of data operation. Size of data. So on a large table, what is the size of the data? It has to actually go to every row and update it to change from int to a big int. And by doing, this alter column, we're doing this all in one really big transaction that is fully logged. So that's why doing the alter table, alter column on a large table is typically not loved by anyone who ever tries it. Hopefully you didn't learn this in production because that's really, really, really painful. And remember that when we are logging things in SQL Server not only has to think about the space for what it's currently logging, but it also has to reserve extra space when it's logging just in case something fails and it needs to roll back. because it is going to need some log space in that worst case, and it doesn't want to not have it, because not being able to roll back would be a huge crisis, right? So we've got to have space for the stuff we're logging, as well as space in case stuff fails. So what are our other options instead of altering the column? Well, one that is fast is you can, if you're using something like an identity column, if you're using identity, you can what's called reseed, which it's like a farming metaphor. You can say, hey, identity column, you're currently at 2.14 whatever billion rows. I now want you to be at negative 2.147 billion rows and change, because there's all this, it's a specific number. So you can set it all the way to the negative value allowed for an int and say, now start moving back up towards 0. You could also reseed it at -1 and say work downwards towards the negative extreme. Reseeding the identity column is fast and it is relatively easy to do. It's a supported operation, but I've never really found a change approver in a change management situation who hears the description of this and is like happy. They usually say, well, this sounds like an awful temporary measure. Now, admittedly, it did take us a while to get to 2 billion probably and change. We've got a lot of room on the other side. In fact, exactly the same amount of room. But they also start thinking about, well, is anything going to go wrong if we have these negative values? Could we hit a weird bug? And you've probably never tried it before. It just makes people really uncomfortable. So I have had people who are like fine with it and comfortable with it. But a lot of times people realize, hey, the bigger change that we need is to go to the larger data type. We would rather just do that change and make that happen. So discuss options. A lot of this really has to do with the nature of the table, the nature of your business, and what folks do. Really, what you want to do is not be making this change at the last minute after you've hit error 666. You can check, hey, on all my tables with identity, hey, am I getting anywhere close to hitting the maximum value allowed for this? And can I deal with changing my data type where I need to before I get into a crisis point? And our questioner is actually smart enough to have found this, yes, and is saying, hey, I'm at 2 billion, right? And I don't want to get to error 666 and be reseeding at the last minute or anything. So what I have found in my experience is if you're in this situation like billions and billions served is, then inserting the data into a new table in a downtime situation is the least sweaty, best option, right? When you can get a downtime, creating a new table with the right data type, with the new data type, right? The big int in the new table. You say, I'm going to have my identity on it, but I'm going to allow insert. So set identity insert on for the new table. I'm going to insert all my rows into the new table, and I'm in an outage, so I've locked everything out. I'm not having to worry about data changing. I'm going to insert all my rows, and I'm going to use some tricks to make sure that I don't have to log every single row. I'm going to get minimal logging in SQL Server, and then I'm going to create all my indexes and constraints and make the new table match the old, and then I'm going to switch them around. I'm going to fix up my identity so that new inserts do generate new values, and I'm going to move on with my life. And that switch around, you got a lot of options for the switch around. You could create the new table in a new schema and then do a schema transfer. You could do renames. Whatever you do, you're going to want to practice it against a restored backup first, because you're still going to need a bunch of space. You're going to need transaction log for creating those indexes to look like the old stuff. Minimal logging does still do some log, just the minimal logging. So you're going to want to test it to say, how long is it going to take and all of that stuff. Test it 8 ways to Sunday, keep the old table around more, and then finish up your outage. The way that you get minimal logging, it's actually really not hard at all, is the good news. The hardest part may be just figuring out your recovery models and backup plan. To minimize logging, you need to be in either the simple or the bulk logged recovery model. And that's because with the full recovery model, SQL Server needs to be able to restore to a point in time, at any specific point in time that you might have within a transaction log backup. It needs to be able to get right to that instance. So it needs to have full logging of everything that's going on. You can switch into what's called the bulk logged recovery model. And with bulk logged, it will allow things like minimal logging. There is a catch. There's always a catch, right? Well, there's really two catches. With bulk logged, if you have one of these bulk logged or minimally logged operations within one of your transaction log backups, you lose that ability to restore to a point in time for that entire log backup. So you're giving up point in time recovery for the entire database, right? Not just that table, the entire database. Also, it still has to back up all the changes you make. So if I start doing a lot of bulk operations and then do a log backup, I'm going to have to back up the log for everything I did. It will read it from the data files instead of the transaction log. That's the trick as to how it works. But that may be a big, long, slow log backup. So I may want to test and plan for that if I'm thinking about using bulk logged. Now, and I'm still thinking about this as an outage situation, right? Because we're talking about minimal logging with this whole table rename thing. I could also do the simple recovery model during my outage, right? I'm kicking everyone out. Nobody's changing things. So it's probably fine that I'm losing point in time recovery, right? Because I'm kicking everybody out. I could switch to the simple recovery model and then I won't have that big log backup. However, I do still have the concern that if I'm normally in the full recovery model, by switching to simple, or even if I'm normally in bulk logged, by switching to simple, I am breaking my chain of transaction log backups. And when my outage is over, I'm going to need to create a bridge for my chain of transaction log backups. And I'm going to need to do that by either doing a full or a differential backup. The differential backup, it is an option to sort of create this bridge for your broken log chain. Of course, a diff is only good if you have the related full, but also, depending on how many changes I'm doing, my differential backup may have a ton of stuff to back up, just like that backup I was talking about in the bulk log scenario, and it might be really big and it might be really slow. So expect to have a pretty big backup at the end of your outage, and the exact backup sequence that you choose it, based on your storage, your performance, your requirements, all that stuff. There's no one size fits all here. These are just the things to be aware of when creating your plan. If your database is already in the simple recovery model normally, like you don't need point in time recovery at all, you don't need log backups, then your life is easier because you're already in simple. In that case, the only thing you have to worry about is making sure that a backup isn't running while you're trying to get minimal logging, because backups running will keep minimal logging from happening while the two things can't coexist, right? So once we're in a recovery model that allows bulk logging, actually getting minimal logging is pretty easy. If you're on SQL Server 2008 or higher, because this is actually, there are perks for this that were added in 2008. If you're on ye old unsupported SQL Server 2005, you're going to have to do some searching for extra syntax using open row set bulk and weirdness. But if you're on a supported version of SQL Server, namely SQL 2008 and higher, and you're doing an insert into a heap, a table with no clustered index and no indexes on it, all you generally have to do is use a tab lock hint on your insert to say, I'm the only one inserting into this table. And it will do very basic logging at the very beginning of the insert, and then it will only keep track of the extent where it's putting the information, so that if it has to, it can undo it, because it's like, oh, I know where I put it. And it will use much less logging for that inserting, and then doing less logging usually, depending on your storage and performance, usually results in a much, a faster insert than if you were logging every single thing you were inserting. There is a fantastic white paper that Microsoft put out. It's called the Data Loading Performance Guide. So once again, Data Loading Performance Guide. If you're doing inserts into any tables, big bulk operations, you want to read this white paper. It has a table in it that says, okay, if the table has a clustered index, here's how to get minimal logging. And it'll tell you, do you just need to use the tab lock hint? Do you have to use trace flag 610, which was added in to help with minimal logging? And it'll help your guide. So I really recommend that white paper. Now, sometimes you just can't take the downtime for this. Sometimes you're like, well, that sounds great, Kendra, but that's going to take hours and I can't take an outage of that time period. Well, in that case, you're just going to have to be crafty and you're going to have to write custom code. So typically when folks need to do this, and again, this is going to take some time. So you really want to find out ahead of time, am I running out of integers? In this case, you need to decide on what way you want to keep track of data changing in the table, because you can't take an outage. Typically means the table has changes happening in it. Rows can be inserted, updated, or deleted. So sometimes people do triggers to capture the insert, updates, and deletes and put them into another table and say, okay, here's the changes that came in at different times that we're going to need to apply later. Sometimes people do change data capture to do that, which is a built-in feature in SQL Server. But basically, you got to say, okay, well, we're going to be making a copy of this. What's all this stuff that's been happening since we started making the copy that we need to apply to our other table? You create a new table with the BIGINT. Nobody is using it yet. And then you populate that new table. Now, because people are using your database, you don't want to do a big transaction. And you're probably in the full recovery model. You're not going to get minimal logging anyway. You're going to do this in small batches so that, well, I mean, small being not the whole table, but as large as you can, you're going to try to populate that second table behind the scenes so that it matches the first table. Now, it is kind of hard to make a copy of something while it's changing. You could use a database snapshot to say, okay, I'm going to populate the second table as of 10 a.m. on Monday. And once I have that completed, now I'm going to take that. I've been tracking what's happened since 10 a.m. on Monday. I'm going to apply all those changes to my secondary table, get them in sync, and now just sort of automatically keep the second table up to date. Then eventually you get all the indexes and stuff on the second table, make it identical, and you have a quick outage. When you switch it in and change things out, you could do the schema transfer, you could do the rename, etc., etc. It's all a lot of work, right? So if you can't take the outage, it's not impossible. If you're careful, you can do this very elegantly, but it is definitely work for sure, and something you're going to want to really practice and kind of orchestrate behind the scenes. The more complex the relationships between your tables, and if you do have things like replication, right, the more complex this gets. I have worked on some cases where we were doing big schema changes in a multi-terabyte database, and it was complex enough that we actually used some really special SAN techniques to use SAN snapshots of the data at a given point in time to stage the data in a new database outside of production, and would periodically refresh the snapshots and update the samples. And then eventually, when the production change came around, the new databases were moved in and custom code was run to change logic to use the new tables to minimize the amount of downtime, because just making the schema change in production directly would have been just a hugely slow task, right? So the more data you have, the more you kind of want to look at what can we leverage in our environment to do as much as we can outside of production and minimize that downtime window. Now, it is kind of tough to take on this problem, but you are not the only one. A fellow named Kenneth Fisher has a blog called SQL Studies that I really like. He recently wrote a great post about this, about his experience with altering a column in a 750 gig table. His article is named Altering a Column in a Large Table, a Case Study. So search SQL Studies and go to his site and check out that post. There's also, if you're interested in the internals behind how this stuff works, like what is SQL Server actually doing when I alter a column? Remus Rusanu wrote a great article on his website called SQL Server Table Columns Under the Hood. So search Remus SQL Server Under the Hood to find that one. Thank you for joining me this week for Dear SQL DBA. If you're enjoying the podcast, I would really appreciate if you reviewed it on iTunes. I'll see you again next week.